Good morning and welcome back to our physics class. Today we are going to discuss about refractive index. In the last class we already discussed about the ray passing through a glass slab. When a ray of light is passing through the glass slab, how it moves, that we already discussed. So the light is bending. So why it is bending? How much it will bend? All those things we discussed. So there again we discussed about the law of refraction. The first part, the incident ray and the refracted ray and the normal at the interface all lay in the same plane. That one we discussed. And the second part when we discussed, that is the Snell's law. Sin I by sin r is equal to a constant, or sin I by sin r is called as refractive index. Sin I by sin r is equal to n. So that n is the refractive index. That is what we discussed is sin I by sin r is equal to n. This n is called as the refractive index. Now we have to study more about this refractive index, or we have to discuss about refractive index in detail. So actually when the light is moving from one medium to another medium, why it is bending? The main reason for bending is in different medium the speed of light is different. That is, when the light is traveling through vacuum, it is having one speed, and when the light is traveling through air, the speed changes a little bit. When the light is traveling through water, again the speed changes. And if it is glass or ice or diamond or whatever be the medium, the speed is different. So when the speed changes, the wave or the light ray bends. Now, how much is the speed? And that speed is depending on the medium itself. So we have a constant for this medium which relates the speed in the medium and the speed in the air or vacuum, or we can say the relation between speed of light in one medium to other medium, that is expressed in terms of refractive index. So refractive index is actually giving an idea about the speed of light in that medium. So if you have two medium, for example medium 1 and 2, n1 and n2, then the speed of light in n1 and n2 is different. Then the refractive index of the medium 2 with respect to medium 1, that is, we will write like this, n21. n21 means refractive index of the second medium with respect to first medium. So this is the ratio of the speed of light in second medium and first medium. So when you are writing it, it is the speed of light in medium 1 divided by speed of light in medium 2. The refractive index n21 is given by v1 by v2. So ratio of the speed of the light in first medium to the second medium. So in the denominator second medium is coming. So the first medium is coming in the top. So the refractive index of second medium with respect to first medium is given by speed of light in the first medium divided by speed of light in the second medium. So you should not have confusion in that one. So for that one, if you take speed of light in air and or you take in vacuum and glass, then refractive index of glass means it is the speed of light in air divided by speed of light in glass. So you know one thing, the speed of light is maximum in vacuum. The speed of light is maximum in vacuum, and this speed of light in vacuum is given by c is equal to 3 into 10 to the power 8 meter per second. This is called as c. C is the speed of light. Okay, so no need of using the word velocity of light, you have to use the word speed of light. Okay, speed of the light is 3 into 10 to the power 8 meter per second. Actually it is 2.99, after that so many digits are there, so approximately we can tell it as 3 into 10 to the power 8 meter per second. And the speed of light in air also is almost same, very small difference is there. Okay, so we can take in air also almost 3 into 10 to the power 8 meter per second only. Okay, so the speed of light in vacuum and air we will take almost as same. Exactly it is not same. Speed of light is little bit less in air comparing with vacuum, but that change is negligibly small. That's why we can take speed of light in vacuum and air as this much, 3 into 10 to the power 8 meter per second. Now, if you take the refractive index, already I discussed refractive index is speed of light in first medium divided by speed of light in second medium, very simple. Now if speed of light in first medium and second medium is given, you can calculate the refractive index. Or if you know the refractive index and speed of light in one medium, then you can calculate for the other medium also. But when we studied about the density, relative density and all in 9th standard, there what we done is we discussed about the relative density. That is, we know one density of water. Density of water is a very well known thing. So we compared everything with the density of water. Like that here, the refractive index when we are calculating, we will compare everything with vacuum. That is, we will represent the refractive index of any material with respect to vacuum. That is called as the absolute refractive index. So absolute refractive index means the refractive index of a medium with respect to vacuum. The refractive index of a medium with respect to vacuum, that is called as absolute refractive index. In that way, what will happen? This first medium will become vacuum. So the absolute refractive index of a medium, I am writing Nm, is given by first medium is vacuum. So speed of light in vacuum is c. So it will be c by speed of light in that medium. Okay. So this point is very, very important. That is, absolute refractive index means we are comparing the speed of light with a vacuum divided by that medium. So you know one thing, the speed of light is maximum in vacuum. So whenever we are calculating the absolute refractive index of any medium, it should be more than 1, because speed of light in vacuum is 3 into 10 to the power 8 meter per second. If you take any other medium, the speed will be less than that one. So the absolute refractive index. So I am stressing the word absolute here, but in general we will simply tell it as refractive index. The refractive index of glass is 1.5 means it is absolute refractive index. If it is not absolute refractive index, we will tell refractive index of glass with respect to water is this much. Refractive index of glass with respect to air is this much. If it is not mentioned, then you take it as the absolute refractive index. So absolute refractive index means refractive index with respect to vacuum. So speed of light in vacuum divided by speed of light in that particular medium. So one more point which I already told you, the speed of light is maximum in vacuum. Refractive index of one medium with respect to other medium, it can be greater than 1 or less than 1. So here from this equation itself you will understand when it will become greater than 1 and when it will become less than 1. See here, when we are comparing speed of light in vacuum with respect to glass, it will be greater than 1. That is refractive index of a denser medium with respect to rarer medium will be greater than 1. Then what is denser medium and rarer medium? We are talking about the speed of light in different medium. So the speed of light can be less in one medium and more in the other medium. So where the speed of light is more, that is called as the rarer medium. And where the speed of light is less, that is called as denser medium. So a denser medium means in that medium the speed of light is less. So it is not at all related with the density, the mass density. For example, if you take the case of kerosene and water, the density of water is more than kerosene. But when we think about this light, the optical density, there the density is more for kerosene. The refractive index is more for kerosene. So whenever we are using the word the optical density and our normal mass density, that is not related. That can be according to the same order, it can be opposite also. That is not at all related. So the denser medium means the speed of light is less. So if you take the refractive index of different material, already we know the refractive index of vacuum, how much it will be? Speed of light in vacuum divided by speed of light in vacuum itself. So it will be 1. The refractive index of vacuum is 1. And refractive index of air is also 1 for our calculation. The exact value will be 1.0003. That is 3 zeros will come there. So it is almost 1. So for calculation you take refractive index of air as also 1. So vacuum it is 1 and for air it is 1.0003. And if you take the case of water, it will be 1.33. And if you take the case of ice, it is little bit different, 1.31 it will come. And for glass, most of the glass you will take it as 1.5. But 1.5 is not the exact value, because there are different types of glasses. We have flinty glass, pot glass, like that, different name is there, different types of glass is there. So it will be 1.52, 1.55, 1.6, like that, different types of glass, different value will get refractive index. So what is the meaning of that one? The speed of light in glass is less than water. That's why refractive index of glass is more. Now if you take other something like the precious stones and all, they have the higher refractive index, ruby, sapphire and all, 1.6, 1.7, that range it will come. And the highest is for the diamond. Diamond is having the highest optical density. That is coming actually 2.42. 2.42 is the refractive index of diamond. So what is the meaning of that one? Light's speed is lowest in the diamond. So if you take diamond, the speed of light is very less comparing with other. So what is the speed of light in diamond? How we can calculate? For example, this equation itself we can use. Okay. Otherwise you can use this equation. So in the case of diamond, we know the refractive index is 2.42. 2.42 or 2.4 only you take. That is equal to C by Vm. That is velocity in diamond. So Vm is equal to C, that is 3 into 10 to the power 8 divided by 2.4. Like that you can calculate for any medium. So if you have any refractive index of a particular medium, then how to calculate the speed of light in that medium? Just C divided by refractive index you will get. Or if you know the speed of light in that medium, how to calculate refractive index? C by that one. So you can do in any way. So if refractive index is available, you can calculate what is the speed of light in that medium. Or if the speed of light in that medium is given, then you can calculate the refractive index. All these things what we are discussing is about the absolute refractive index. If comparing to one medium, other medium means you need the speed of light in both medium. For example, you want to calculate the refractive index of glass with respect to water. Then speed of light in water divided by speed of light in glass you have to use. So in that case you can see here, when you are taking refractive index of glass with respect to water, speed of light in water divided by glass, speed of light will be more in water. So when you take the refractive index of a denser medium with respect to rarer medium, the refractive index will be more than 1. That is the refractive index of glass with respect to water. If you take, it will be more than 1. If you take refractive index of water with respect to glass, it will be less than 1. So if you take the refractive index of diamond as 2.4, then what is that? 2.4 because the diamond is denser medium comparing with the vacuum. If you take the refractive index of vacuum with respect to diamond, then it will become 1 by 1 point. So it will become less. So whenever we are seeing the refractive index as less than 1, then what you should know? You should keep in mind that we are calculating the refractive index of a rarer medium with respect to denser medium. Whenever we are calculating denser medium with respect to rarer medium, it will be always more than 1. Now, when this light is traveling from rarer medium to denser medium and denser medium to rarer medium, it will bend. We already discussed. So we will think how this is bending, in which way it will bend. That's what you consider the light which is coming from a denser medium to rarer medium. That is, you have denser medium on the top. That is, you have glass here. Okay, here N1 is there. This is glass, and you have air below this one. In this case, you see here, when the light is coming from denser medium to rarer medium, the light will bend away from the normal. This is the normal. It will go away from the normal. So it actually should come like this. It is going that side. When the light is coming from a rarer medium to denser medium, that is, here you have air and here you have glass. In this case, what happens? The light will bend towards the normal. That also you have to remember. When the light is coming from a rarer medium to denser medium, it will bend towards the normal. When the light is coming from denser to rarer, it will bend away from the normal. So this one you can check in the previous glass lab experiment also. First, when it came from air to glass, it bent towards the normal, and when it is coming out from the glass to air, it is bending away from the normal. Now, one more point which we have to discuss based on this one is where generally people will get confusion. This N21 is given by V1 by V2. That is refractive index of 21 means refractive index of second medium with respect to first medium is equal to V1 by V2. Now, this is in terms of velocity. Now, if you know the refractive index of two medium, for example, you know the refractive index of glass and you know the refractive index of water. You want to calculate the refractive index of glass with respect to water. That is, you know the refractive index of glass separately, you know the refractive index of water separately. These two refractive index is actually the it is the absolute refractive index. Now we have to find the relative refractive index of glass with respect to water. In that case, what we have to do is, we have to use the equation N21 is equal to N2 by N1. This is important because when we are taking velocity, N21 is V1 by V2. But when you are taking refractive index with respect to, or we are calculating from refractive index itself, then N21 is N2 by N1. That is, if you want to calculate the refractive index of glass with respect to water, if you use the velocity, then speed of light in water divided by speed of light in glass. But if you are taking refractive index, then refractive index of glass with respect to water is refractive index of glass divided by refractive index of water. So this is becoming opposite. If it is velocity, it is V1 by V2, and if it is refractive index, it is N2 by N1. Don't confuse in that one. Okay. So what are the types of question which can come for 10th standard based on this one? Directly they can ask the laws of refraction, then what is Snell's law they can ask, and they can ask what is refractive index and what is absolute refractive index, and this equation also we can ask. And next level, as numerical problem they can ask by giving the speed of light in one medium and another medium, what is the refractive index of this one, just V2 by V1 we can ask. Or opposite, they are giving the refractive index of a particular medium, what is the speed of light in that one, like that also. Everything based on these two equations. And refractive index of one medium is this one, and refractive index of the other medium is this one. Then what is the refractive index of the first medium with respect to second medium, or refractive index of second medium with respect to first medium? That also they can ask. And one more type question generally coming is, they will give a list or a table. In that one they will give different materials. For example, they are giving air, vacuum, and many materials like glass, water, ice, and rock salt, like that. All the refractive index will be given. From this refractive index, you have to arrange these materials according to the speed of light, ascending order or descending order. So what you should keep in mind is, where the refractive index is more, there the speed of light will be less. So when you are writing according to the speed of light, the speed of light is minimum in diamond. By seeing the refractive index at 2.4, don't think that the refractive index is high, so it will come in the end. The refractive index is high means speed of light is minimum. Okay, such questions also can come. Okay, so now you practice the questions, just go through the part in the textbook and you practice this one, and previous questions also, what are the questions came from this topic, all those things you can prepare now. Thank you.